Okay, Bismillahirrahmanirrahim and Assalamu alaikum. This is a repeat recording of lecture number 10. I guess the last time I recorded, there was just my voiceover and the screen froze at the desktop, so you couldn't see anything. Although I went through the whole thing, but it was unfortunate that those 2, 3, or 4 hours at least we lost those that time. But in any case, this is a repeat of what we talked about in that lecture. So we'll get started. First of all, in that lecture, we talked about these things. First, we talked about some important jargon related to programming. I have uploaded the PDF slides of that particular jargon on Google Classroom. I guess you have went through all that. So here we will talk about that. Then in this part of for this part of the course, we are going to use a software called GNU Octave or GNU Octave. Okay. So last time I showed you how to download it and install it. I have already downloaded the file. It's around 325 MB file. I'll show you where you can download it from. We'll go through that, and I have uninstalled it and we'll reinstall it again. So I'll show you how to install it. Again, this is pretty simple. It's not that complicated, but still, assuming that you haven't done any of this before, so we'll go through it again. Then we'll start using the Octave software. Okay, so Octave, we'll start using the Octave command window. In the important jargon, we'll also talk about variables. What are variables, and what are the conventions that are followed to name those variables. In fact, they are not conventions, they are more of rules. You have to follow those rules, and if you do not follow those rules, you will generate an error. The code that you want to write, it will not work. Then we'll talk about scalars, vectors, and matrices. I'm sure you know about all these things. In programming, in computer programming jargon, we call them as arrays. Okay, and arrays can be unidimensional or multidimensional. So we can have single or multi-dimensional arrays. We can have single or multi-dimensional arrays. So you can think of a vector as a single dimensional array, and you can think of a matrix as a multi-dimensional array. So a single dimensional array just has a row or a column, while a multi-dimensional array has rows and columns. So you can think of a table as a multi-dimensional array, two-dimensional array. We can have three-dimensional array. So you can imagine a three-dimensional array as data organized in the form of a cube. So it has length, it has width, as well as it has depth. So it has data stored along all three dimensions. And similarly, we can have higher dimensional data as well, more than three dimensions. We can have all that. Then in this lecture, we also talked about arithmetic operators. So then with arithmetic operators, there are certain rules that are attached. These rules are the rules of precedence and associativity. So we'll talk about these rules as well. First, let's see how you can find GNU Octave. Okay, so Octave, you can simply call it as Octave, GNU Octave or GNU Octave. Now, GNU has a huge history behind it. In order to find out the software, you can go to Google and you can search for either GNU Octave, sorry, GNU Octave, okay, or you can simply search for Octave. Now, GNU is basically uh, uh, short for what? I guess it is. You can find it out. What is it like? What does this particular abbreviation means? But I guess it is a recursive kind of abbreviation. It says GNU is not Unix. So G is for GNU and N and U are for not Unix. So basically it is part of the free and open source software movement. Okay, so the movement was founded by I guess Richard Stalling. I don't remember the correct name, but He founded the Free Software Foundation, and the basic idea of Free Software Foundation was not to create free software, but to create a software that is open source. So if a user buys a software, the user must be allowed to have the source code of that software, so that if the user wants to improve or amend that software, so he or she is able to do that. Okay, so perhaps this was the basic idea of it. It may be kind of a little blurred in my mind, but you can go through it. So the key point is that GNU Octave, the software that we are going to use and download, this is free. So when you search it or Google it, so this is what you get in its description. So Google describes it as a high-level programming language. So GNU is a high-level programming language. We'll talk about high-level programming languages. Now, computer is a programmable machine. By that we mean that you can instruct the computer to do different things. So say for example, right now the computer is executing the Firefox browser code. So right now it is acting as a browser. At the same time, it is displaying this PDF document. This is a different software, a different set of instructions, a different program. And at the same time, it is recording this video. So both the screen and the voice, my voice, these are being recorded. So at this moment, like, it is also acting as a recorder, a video camera, or a screen cam, or a mic. So similarly, it is also running the different set of instructions, Microsoft PowerPoint. So at any given time, this computer can be instructed to carry out or perform different jobs. So this is one, you can think of it as one job, running Microsoft PowerPoint. This is another job, running this software OBS Studios, and it is used for recording the screen and audio and all that. This is another job, displaying PDF documents, and this is the browser. Okay, so computer is a programmable machine, and you can instruct it to do or execute different tasks for you. And how do you do that? So you use programming languages for that. So we know, we have discussed that the computer, it can only understand machine language, and machine language is the language of ones and zeros. Okay, so we have talked about that. Everything, data that needs to be stored or processed inside a computer, whether it is audio, whether it is video, whether it is text, images, it has to be converted or stored in the form of ones and zeros. And similarly, when you want to instruct this computer to do something for you, those instructions must also be in ones and zeros, because that is the only language that this computer understands. But ones and zeros are difficult for us to understand, and you must have had a good idea about it in your midterm exam. So binary is not easy. Binary can be difficult, especially if you have to write like huge amounts of instructions in binary. Okay, so then what should you do? What do you need to do? You need to use high-level programming languages. High-level programming languages are close to English. So in those languages, the instructions are more English-like. Okay, so GNU Octave is one such high-level language. There are plenty of other high-level languages: C, C++, Java, Python, Basic, Visual Basic.NET, C Sharp, and like there are plenty of others. So we are only going to focus on GNU Octave. GNU Octave is a free counterpart to a more popular uh, programming language or environment called Matlab. So Matlab is more extensive and more sophisticated. It comes with a lot of toolboxes and a lot of other tools which allow you to do almost anything on using Matlab. But Matlab comes at a price. It is a proprietary software. It is not free. You have to pay for it. Okay. But GNU Octave is a free version of. It's not a copy of Matlab, but it follows the language and grammar of Matlab. So you can do whatever you learn about Octave, you can apply that to Matlab as well. Okay. So you're learning two softwares at the same time. So you Google GNU Octave, you click this link and go to the GNU Octave web page. You'll come here, and here like you can click on download, so it will take you to the download page. When you get to the download page, you get these different options. So one of the options is source. You can download the source code of GNU Octave. So source code means the instructions, the actual instructions in high level programming language that help create the Octave software. So you can get that high level source code for GNU Octave, and that is why any software that is part of the GNU project, so you can get the source code of that software. Okay, and if you're good enough, you can like modify that software. We want GNU software for Microsoft Windows, so you can click Microsoft Windows here, and here you have plenty of different options for downloading GNU. I downloaded this particular installer. This is a 64-bit installer. I have a 64-bit Windows, and if you click here, so it will ask you whether you want to install it or not. So then you can say yes or no. Okay, so we want to install it, so you need to save this file. Okay, I've already downloaded this file, but this is the procedure. Click on that and then save this file. Okay, if you have a 32-bit Windows, so you can click on this installer. Okay, since we have already downloaded it, so I'll cancel this thing here. I don't want to waste my bandwidth. And once you download it, so depending upon your settings, it will be downloaded on your computer into a particular folder. My settings say that everything I download goes to the downloads folder. It is a system folder, so it goes to the downloads folder. Here is the Octave installer. So once you have installed it, so all you need to do is double click it or select it and then press enter or right click. Okay, so right click on it and then run as administrator. Okay, or open, so both will work the same. So let me run it as an administrator. So why do you need to run it as an administrator? Because usually the administrator account is very powerful, like the most powerful account. It has the most privileges on your computer. It can do almost anything. And then there might be some accounts though that may be limited. They may not have privileges to install a new software or things like that. Okay, so it asks us, do you want this software to make changes into your computer because it comes from an unknown publisher? Yes, we want to do it. So then this software will like start running. This is the GNU Octave setup. Usually setup, the name setup or installer, it is the name of any software that helps install some software. Okay, so setup file is the file that allows you to install a particular software. So if you want to install some software, you need to search for the setup file. Okay, setup helps you set up that software on your system. Or you can look for the installer. So both the installer or the setup file, they help you install a particular software on your system. So this is a wizard. Just follow these instructions, read things carefully. Let's go to next. Agree. Yes, we agree to the software agreement. Do you want this software to install for anyone using this computer or just you? You want anybody to have access to this software? Okay, so do we want to create desktop shortcuts? Yes, we want to create desktop shortcuts for GNU Octave. So that you can double click on that shortcut and launch this file. Register.m type file type with Octave. Later we'll learn about writing script files, and script files will be stored in files with the extension .m. So do you want to register .m file type with Octave so that whenever you double click on that file, Octave opens that file? Yes, we want to do that. Okay, so press next. And then where do you want to install it? So I want to install it in the default directory. It is in C, program files, GNU Octave, and this. If you want to change this directory, you can browse and specify another folder where this software can be installed. Okay, so but we want to have it here. It requires 1.8 GB space, and right now we have 37 GB on C, so it is fine. So let's install it. So the installation will begin and it will take some time. You can look at the details like what is happening. So right now it is extracting softwares from this installer. Okay, so this installer has been compressed. Many files have been compressed into this installer so that its size is small. So right now the files are being extracted and then they will be installed. So I guess once you select show details, you cannot undo that option. So let it go on and we can minimize this window, and in the meanwhile we can go and look through some other stuff. Okay, so I hope like you will be able to find the software and like download and install it. Now let's get back to the important jargon or definitions related to this part of the course. So I guess we have mentioned or talked about many of these before. We'll quickly go through it again. So you know what a computer is. A computer is a data processing machine, okay? And whenever we say a computer, so we mean by that we mean a digital electronic device, okay? It's not a computer can be any type of device, but what we mean by it is a modern digital electronic device. And I hope you know what digital means, okay? So we have talked about it in a lot of detail. Now, a data processing machine processes data. What is data? Data is the plural of datum, which means facts. So anything, any fact, quantitative or qualitative, can be data. For example, your height, or for example, the grades of each one of you in a particular course, or for example, your date of birth, the entire class, or your CNIC number. So this is all data. This is all data. Values for all these quantities, they form data. What is information? So data information can be used interchangeably. Many authors, they tend to use these two terms interchange. They mean the same thing by both data information, but we will make a slight distinction. Information is something, it is basically data that is relevant to you, okay? And usually you get it after some processing. For example, we have the heights of all the students in the class, and we are interested in the average height of a student in a class, okay? So now average height is something that is information. So how do we find the average? We add up all the heights and divide it by the number of students, so we get the average. So that is the processing. You sum all the heights and you divide it by the number of students in the class, so you get the average height. Similarly, if we want to know the height of the tallest person in the class, so we need to find the maximum value of the height in your class. So that is also information. So data is just raw data, raw facts, and information is something that you need, that you require. So for example, we want to find out the oldest person in your class. So we have all the birthdays, and we can find out who is the oldest or who is the youngest in your class. So all the birthdays, that is data, and information is like who is the youngest person in class. That is information, and we get this information by processing all those birthdays, okay? So how do we do processing? In order to do processing, we need to execute a sequence of instructions, and that sequence of instructions is called a program, okay? So a program is basically a sequence of instructions, and whenever we say a sequence means that there is order in those instructions, okay? So one instruction is executed, then after that another is executed. So there is a particular order to those instructions. And program, like we are right now, we are talking in the context of computers. So basically it is a sequence of instructions for the computers. But program is a general term that you might have come across, like if for example you receive an invitation card to some wedding or some function, so they mention the program, okay? So like when would the guests arrive, when would the dinner be served, when would the barat go, and all those things. So there is a sequence and order to that, and for each activity some time or something like that is specified, okay? If you go to a more formal function where there they are going to be guests, and they are going to be, for example, the convocation. If I hope, like many of you, when you graduate, so you will attend the convocation ceremony if things are normal. And in the convocation ceremony, like there's a full program. The guests, they arrive, the students, their parents, they are seated. Then the chief guest arrives. Then there is the convocation starts. There is a parade that enters the convocation venue, and all these things. So there are plenty of activities, and those activities are ordered. They are performed in an orderly manner, and we call it as a program. So a program is much more generic word. And similarly, if you want to let us understand programming through another analogy. So a program is a sequence of instructions, but it those sequence of instructions, they operate on data. So you can think of it, you can understand it using another analogy, and that is of cooking or baking something. So if you want to cook something, you need to follow a recipe. A recipe is basically two things. One is the ingredients, and the other is the sequence of steps that you need to follow to in order to mix and cook those ingredients. Okay. So if you want to say, for example, make achari kadahi, chicken achari kadahi. Okay. So in order to make that chicken achari kadahi, you need a certain set of ingredients. So you need chicken, you need achar, and you need oil, and you need salt, and you need all those things. So those are your ingredients. You can think of the ingredients as data. And then you need to follow a set of instructions. Okay, so first turn on the burner, then put the frying pan on the burner, and put in some oil, and then add chicken and cook it for some time. So this is the sequence of instructions that you need to follow. And these instructions, they operate on the data, on the ingredients of the recipe. Okay, and the end result is, the output is chicken achari kadahi. Okay, so that is the output. So in the same way, in much the same way, a program is a sequence of instructions that operates on some input data, and it gives you information as an output. Okay, so I hope, like, you will understand this thing through this example. Programmable machine is a machine that can be instructed to do something, usually not just once but many times. This laptop that I'm using, it is a programmable machine. The actual programmable component in this machine is basically the Core i5 processor that it has. So the microprocessor is the programmable machine. So we can instruct the microprocessor to do different things, to execute different softwares. Right now it is executing Adobe Acrobat Reader. It is also executing this installer, Gnu Octave installer. It is also executing this Microsoft PowerPoint. It is also executing this OBS Studio software. So it is recording my voice and recording this screen. So this is also happening. Similarly, when I click on the browser, so it basically is also displaying this HTML page. Okay, so it is acting as a browser as well. This is called programmability. So we are instructing our microprocessor to execute these different types of software. So this, we can do it because this is a programmable machine. If it weren't a programmable machine, then we would not be able to do it. Okay, programming. What is programming? Again, we have mentioned and used this term, so I hope it is clear, but let us go through. Instructing a machine to do something using a predefined set of basic instructions. Now we've talked about this predefined set of basic instructions. We have called it as the instruction set of a computer. Okay, as the instruction set of a computer. So every computer or every microprocessor, it has an instruction set. Instruction set contains a set of basic instructions that it understands, that it knows how to execute, and then we combine those instructions to make more complex software. Okay, so programming is basically using or picking up those instructions from the predefined set of instructions and instructing the computer to do those things. Okay, now you can do programming in different languages. In order to do programming, in order to instruct the computer to do something for you, you need to use a programming language. Okay, now the language that computers mostly understand, it is the machine language, or it is also called a low level language. Okay, So language, what is the language? The language that we use to instruct a digital computer to carry out a certain task. It is called a programming language. Now it has different types. One is low-level language or machine language. That is the language that the computer understands. Okay, these are digital computers, these are binary devices, and they can only understand things that are encoded in ones and zeros. So machine language is basically strings of ones and zeros. Instructions in machine language are strings of ones and zeros. So the computers ultimately anything that you want this computer to do, it is converted into strings of ones and zeros. So that is the language that the computer executes. Like it is right now displaying this text in this Acrobat reader window to you. So behind the scenes, machine code for Adobe Acrobat Reader, it is being executed. Okay. So similarly, we are looking at the Firefox window. Behind the scenes, the machine code for the Firefox software that is being executed by our computer. Okay. But as we mentioned earlier, machine language is difficult for us to understand. So we as humans, we are more comfortable in languages that we find easy to understand. And we are usually comfortable with high level languages. High level languages are languages that are more English like. Okay. So they use these English words, and they have this easy to understand syntax or grammar, which we can rules that we can follow in order to do or accomplish something. So we instruct the computer in high level language, but the computer needs those instructions in low level language or machine language, ones and zeros. Okay. Now we talked about before as well that there are plenty of high level languages. There is C, there is C++, Python, Visual Basic, Matlab, or Octave, Java, and there are many others. Okay, so you can use these languages to instruct the computer. But the programs that you will write in these languages, those programs cannot be executed directly by your computer. They have to be translated into machine language. And for that, you need a software called a compiler. So a compiler is a software that translates a program written in a high level language to into machine language. Okay, so a compiler is a software. It takes as input your source code in a high level language, and it translates that source code into machine language. So every language has a separate compiler. C has a separate compiler. C++ has a separate compiler. Python does not come with a compiler. It is basic. It comes with with an interpreter. Python code, Visual Basic code, Matlab code. This code is not translated, okay, into machine language directly. So these instructions are in fact executed. Instructions or programs written in Python, Matlab, Octave. These instructions are executed by a software that we call interpreter. So the interpreter reads an instruction in these languages, and it then asks the microprocessor to execute that instruction. Okay, so there is no explicit translation. There is translation, but those instructions are directly given to the microprocessor. Like there is no file machine language code being generated. Okay, so interpreter is slightly different than compiler. A compiler translates high level language code into machine code, but that translation is like separate than execution. So a compiler takes the high level source code file, it translates into machine language code, stores that machine language code in a separate file. That file is called the executable file. It has the extension .exe, and in order to execute that file, you need to double click on that file and load it into random access memory, and then that file is executed. Okay, but an interpreter works in a different way. So if you need to execute program written in Python, Visual Basic, or Matlab, so what you need to do is you need to run the interpreter for Python code or Visual Basic code or Matlab code. It is one software. That software has to be loaded into the RAM. Okay, and then once that software is loaded into the RAM, so you give it, for example, the Python interpreter is loaded into the RAM, so you give it the Python source code, and it executes the source code. That program instructs the microprocessor to do things so that the Python code is executed. Okay, There is no translation as such. The Python code is not translated or into a machine code. That machine code is not stored in a separate executable file, and that separate executable file, since it is not there, it is not loaded into RAM and then executed separately. Okay, so there is a software that is loaded into the RAM, and that software directly executes the Python instructions, or in the case of Matlab and Octave, the Matlab and Octave interpreter is loaded into the RAM and it executes the Matlab or Octave instructions directly. There is no translation, explicit translation. Okay. Okay, so I hope like I have clarified the difference, although it may take you some time to realize that, but I hope I have done something to make it easy. Okay, next, so what is Octave? We are going to be using the Octave software here, okay, and the Octave programming language here. So this is a slight introduction of Octave. Let us check whether Octave has installed or not. Yes, it has installed. Do you want to show README? No, we don't want to see README file right now. Do you want to run GNU Octave? No, not right now. We'll run it by itself ourselves. Let us finish it. Okay, so let us run GNU Octave. Let us go to our desktop. So right now we have these two shortcuts added to our desktop: GNU Octave GUI and GNU Octave CLI. CLI stands for, I hope you remember, command line interface. So if you run, you can run GNU in the CLI mode or the GUI, graphical user interface mode. In both modes you can run it. If you run it in the command line interface mode, you should run it, you should try it at home. So you will see the command prompt, okay, the black screen, and then you will enter the commands there and it will be executed. And if you run it in the GUI mode, which you can run by double clicking this thing or right click and open or select and then press enter, so you can do that. In that case, you will see a graphical user interface. So you will have menus and you will have a command window and all these things, but it will be more graphical. So it does take some time during loading initially. So let us load it. So this is how the Octave uh, uh, graphical user interface looks like. Okay, so we'll go through it. We'll see. We'll talk about it later. But let us return to our discussion. Okay, so what is Octave? So we've talked about it. Octave is an open source interactive software system for numerical computation and graphics. So you can use it for numerical computation and creating all those plots and things like that. In fact, processing images and all those things. Its stepbrother, the Matlab, it is much more extensive. And Octave is basically, since it is a free version of Matlab, that's why we use it. Its syntax is compatible with Matlab. The way you write instructions, syntax basically is the way you write instructions or different statements. So how do you write those instructions? That is syntax. Okay, syntax is, you can think of it as something close to grammar. It's not exactly grammar, but you can think of it in that particular way, in that particular sense. So the syntax of Octave is compatible with Matlab. So whatever you uh, learn about Octave, that almost equally applies to Matlab. There are other free alternatives to Matlab, such as Scilab and FreeMat. I haven't used any of these, but there are. You can explore these things. You learn about Matlab. Matlab, your seniors might tell you that they extensively might have used Matlab or might uh, need to use it. Okay, so I hope like you will in your senior classes, you will find more uses for Matlab. Now, Octave, just like Matlab is basically an abbreviation for Matrix Laboratory. Mat for matrix, lab for laboratory. So Matlab deals with matrix computations. Okay, so your course on linear algebra, it is very important course. Almost everything can be done with linear algebra. Okay, so even if it is a differential equation and you want to solve it, So you can solve it ultimately numerically using linear algebra, okay? Using linear systems or system by solving a system of linear equations, you can solve a differential equation, whether it is an ordinary differential equation or a partial differential equation. Similarly, if you want to integrate some function or differentiate some function, you can do that numerically. And again, for that, you may not need to solve a linear system of equations, or you may need, depending upon technique. But the point is that matrix computations are very powerful computations. They allow you not only the solution of simultaneous linear equations or system of linear equations, they also allow you to solve differential equations, whether ordinary or partial differential equations. And engineering is mostly all about that. Similarly, they also allow you to do complex computations like the finite element method or machine learning and all that. So you can do all these things by using matrix computation. Okay. Similarly, you can use it for finding eigenvalues and eigenvectors, and you can also use it to visualize data in different forms. You can create all those fancy plots and things like that to visualize data better. Octave has its own programming language, so you can extend it. Like, we'll also learn how to use that programming language. Um, it was developed by Dr. J.W. Eaton, and it is being maintained by him and his team. Those are all volunteers, and we should be thankful to these people for making these softwares like these available. Okay, so Octave, again, it is free, but it is not that like software that is not useful. Plenty of people find it very useful. It is widely used by engineers and scientists, both in the industry and academia. For example, NASA has used it to develop spacecraft docking systems. You must be aware about the Jaguar Racing, Jaguar company. The Jaguar is a brand of cars, and those are Formula One cars as well. So they also have used the software to display and analyze data that was transmitted from their Formula One cars. And then Sheffield University, UK has used it to develop software to recognize cancer cells. And again, you can also use it to do something important, and then it will figure here, okay, who uses Octave. So Octave is a useful software, and it is being widely used by many people in universities, academia, and the industry. The Octave Desktop. So this is what the Octave Desktop looks like, okay? And it has different components. One, this is the command window. Here you can enter the commands, and those commands will do something for you. For example, let us use our first command. The first command is we want to clear this screen or clear the command window. So clear the command window, you have this command CLC, clear command window. You write CLC and you press enter, and the command window will be cleared. So this is the first command, okay? Then we have the command history window. This is the command history window. Any command that you use, it will appear here, okay? So we just use CLC, and before that, like, we have been using this command. I installed this Octave before as well, and then I uninstalled it and then reinstalled it. But some of the files they were not removed, so I have the previous command history as well. If you install it and use it for the first time, you'll only see CLC here, not the other commands. Okay. As soon as you start executing more commands, you'll see this window being populated. Okay. So I have used it before as well, and all those commands that I have used, they're here. Okay, this is the workspace window. It shows us the variables that are basically currently inside the random access memory. So right now you cannot see any variable. Right now Octave has not created any variable. What is a variable? A variable is basically a location in random access memory that is used to store data, but it has a name. So a variable is a named memory location in RAM. Okay, and you can use a variable to store data, and then you can process that data. Okay, So computers are data processing machines. You need to have facility or commands to store data, and then you need to process that data. Okay, so we store data in variables. When we are programming in Octave or any other programming language, so in order to store data, we need to create variables. A variable has a name, it has a class or type, it has dimension, size. Okay, so it can be a vector, it can be a scalar, it can be a matrix. So the dimension will tell you about the size of that variable, and it has value. Okay, so you can see all that information about a variable here. So later we'll create these variables and we'll see all this information about those variables. This is the file browser window, so you can, if you want to open a script file or save something, so you can use this window to browse through your system. Okay, so for the purpose of this course, like I created a folder in my documents. Okay, so we can go to Documents, Introduction to Computing, and then Octave. So this would be our current directory. So whatever script file we create in future, so we will store it here. So right now there is no script file uh, here. What is a script file? A script file is just a text file that contains different Octave commands. So if you like want to execute more than one command, so you can put all those commands in a script file, and then you can execute that script file. So multiple Octave commands will be executed in a sequence. Okay, that is the purpose of script file. So this is the Octave desktop. When you open the Octave desktop, this is what you're going to see. This is the Octave desktop, and these are all the windows that you see. Again, this is the title bar standard. This is the menu bar. You have these different types of menus. Okay, so you can go through these things, and this is the toolbar. This is your toolbar, and it has these different shortcuts to different commands that are available to you in those menus and all that. Okay. Similarly, the Octave desktop, command history, we've talked about it, the current folder. So this window displays all the files folder in your current folder or directory. Okay, so this is our current directory or folder, and this basically shows all the files and folders inside of it. So right now there are none, that's why it is empty. Variable editor, there is another window, variable editor. It's available here as a tab. You can click on it. So right now we haven't selected any variable. There are no variables, so the variable editor window is like blank, so you don't see anything. But in through this window, like you can directly see or look at the contents of a variable, and you can edit those contents. You can change a variable. Okay. Okay. So this is the Octave desktop, and this is the variable editor. So in this particular case, we have a variable. That's why you can see something here. Okay. Now let's start using Octave. Okay. So first thing is that we can use Octave as a calculator. Okay, as a calculator. By calculator we mean like this is the command window, and on this through this command window you can issue simple commands, and those simple commands can be like simple addition, subtraction, multiplication, division, exponentiation, and all those things. Okay, so you can do it directly here. So for example, you want to find out 256 plus 36, for example. So you can simply enter it like this, 256 plus 36, and then press enter. So you get the result 292, that is the sum. And the sum, where is the sum stored? So Octave creates a variable by the name of answer. Okay, ans. So answer stores the answer of the most recent computation, computation that you performed. So the answer of that computation is stored in the variable ans. If you do not specify a variable to store the sum, it will be stored in the variable ans. Okay. You can also say something like this. We'll do that later if I remember. Now here you see we have one variable that has been created. This variable is ans. It stores the result of this computation, 256 plus 36. The type of this variable is double. We've talked about double. So it is double precision. It is stored as a double precision value. Now a double precision value is stored in 8 bytes. I hope you remember that, okay? And its dimension size is 1 by 1. It is a scalar value, okay? One row, one column, it is a scalar value, and this is its value, okay? So I hope like this is clear, simple. Similarly, you can do other computations. For example, you can say 256 minus 98. What would that be? So it is 158. Now answer stores the value 158. The previous value 292 is gone. It is overwritten. There is just one ans variable. Whenever you perform some computation, that variable will store the value of most recent computation. Okay, so this is how you do addition subtraction. You can do multiplication like this. So for multiplication, we normally use this symbol x, but here in Octave, it is represented by the operator asterisk. So asterisk is the operator for multiplication. Okay, so 52 multiplied by 5, this is 260. Okay, so again ans now stores the value 260. The previous value 158 is overwritten. It's gone now. Similarly, you can do division. 52 divided by 5. So the forward slash, this is used for division. This is the division operator. So these are operators: addition operator, subtraction operator, multiplication operator, division operator. So they specify some mathematical arithmetic operation, okay? And these are all binary operators. So they take two operands: multiplication, division, addition, subtraction. They are all binary operators. They require two operands. 52 divided by 5, this is going to be 10.2, 10.4, sorry. So this is what you get, okay? Similarly, you can also do another operation that is called exponentiation. Say, for example, we want to find out 2 raised to the power 8. That would be 256. So you can use this hat character for exponentiation. So this is the exponentiation operator, okay? This is the exponentiation operator. So you can use it to find the exponent of a number. So we want to find out 2 raised to the power 8. 2 raised to the power 8. So this is going to be 256. This is going to be 256. Okay. So this is how you can use the command window as a calculator. Now you can do more complex computations. For example, you can do that problem that every elementary math student is asked: what is 2 plus 2 multiplied by 2? Again, you can do more complex things, but we are basically going to talk about operator precedence. So these are all arithmetic operators: addition, subtraction, multiplication, division, exponentiation. And whenever you use different operators in an expression, for example, this expression uses two operations, addition and multiplication. So which is going to be performed first, addition or multiplication? Okay, so in order to answer these questions, you need to understand the rules of precedence. So the rules of precedence basically state like which operation is going to be performed first and which later. So I hope you know multiplication has a higher precedence than addition. So first multiplication will be performed and then addition. So it will be evaluated in two steps. This expression will be evaluated in two steps. First this multiplication will be performed and then this addition will be performed, okay? So this is how it's going to be performed. Let us add another slide here, and this is about operator precedence, okay? So we have this expression 2 plus 2 multiplied by 2. So how is it going to be evaluated? So first of all, the multiplication will be evaluated. So first we will evaluate the multiplication. So 2 will multiply with 2. So it becomes 4. So 2 plus 4. So like this is the first step. So first this multiplication is evaluated. Okay, one step. Then this addition will be performed. So 2 plus 4 is 6. Okay, so it will be performed in two steps. This operation will be performed in two steps. Okay, the layout. Okay, this is how it's going to be performed. So you can see by the answer, if addition were performed first, then 2 plus 2, 4 multiplied by 2, it would be 8, but it is 6, okay? So you can use this command window as a calculator. You can perform more complex operations. We'll go through certain examples when we talk about operator precedence, okay? So this is, you can read through this material. We've talked about it. Now we have these operators: addition, subtraction, multiplication, division, and exponentiation. These are arithmetic operators. We certainly have more operators of different types. Those are, we have logical operators and other operators, but these are the arithmetic operators. And similarly, we can also use the parentheses. The parentheses are used for enforcing precedence. If we want some operation to be performed first, for example, uh, we have used this command, this expression, so it is part of the history. If you want to access this command, so you need to press the up arrow on your keyboard. So if you press the up arrow, you will access this command. Now we can force the addition to be performed first. We can say first perform addition, then multiplication. Okay, so you can use the parenthesis to enforce precedence. You can use the parenthesis to enforce precedence. So this is how you use it. So anything that is enclosed in the parenthesis, that will be performed first, and then the other operations will follow the rules of precedence. So now the answer would be 2 plus 2, 4 multiplied by 2. So first this addition would be performed. Okay. Again, we said that although your computer is a very powerful machine, but it can only add two numbers at a time. It can only subtract two numbers at a time. It can only multiply two numbers at a time. Okay. So if you have multiple operations, those multiple operations are performed in steps. So first this multiplication is performed, then this addition is performed. Okay. Similarly, in this case, first this addition will be performed, and then this multiplication will be performed. If you press enter, you just see the direct result. But in between, like before you get this direct result, your computer takes a certain number of steps to perform this operation. Okay. Okay. So let us go through the rest of it. So operator precedence. So what are the rules of precedence? Operator precedence basically states, like, if you use multiple different types of operands or operators, sorry, different types of operators in an expression, which operation is going to be performed first? So you should know, you should remember these rules. First, uh, highest precedence goes to the parenthesis, then exponentiation, then multiplication and division. They have equal precedence. Multiplication and division have equal precedence. Okay. So if you have learned something in your elementary classes about the difference between the precedence of these two operations, now is the time to unlearn that. They have the same precedence, but there's another important rule that is called operator associativity that you need to understand, which can affect the result that you might end up with. Similarly, we have addition and subtraction. They have the same precedence, but their precedence is lowest as compared to multiplication and division and exponentiation. Okay, so this is the precedence. First parenthesis, then exponentiation, then multiplication and division, and then addition, subtraction. Okay. Now there's another rule that is also important, and that rule is associativity. Okay. So what does associativity tell us? If you are using the same operation, for example, let us look at this expression. We have this expression 5, say 5 plus 2 plus 6 minus 3 plus 1. Okay, say for example we have this expression. Now in this expression, if you see, let me increase the size, font size, sorry. So in this expression, if you see, like, we have multiple additions and subtractions. and all the additions and subtractions have the same precedence. So now the question might arise, like, which operation should we perform first? Okay, so if you have operators of equal precedence in an expression, multiple operators having the same precedence in an expression, then which operation should you perform first? So that is basically determined by, let me correct this, precedence. Okay, we need a C here. Okay. So which operation should be performed first? That is determined by this rule called the rule of associativity. Okay, operator associativity. What does it say? It says that if you have, for example, uh, multiple exponentiations, so you need to perform those exponentiations starting from the left. Leftmost exponentiation should be performed first, then the next one, then the next one. Similarly, if you have multiple multiplications or divisions, you need to start from the left side. The leftmost multiplication or division needs to be performed first, and then you should go towards the right. Similarly, the same is the case with, fortunately, all these operators have associativity from left to right. So even if there are multiple additions or subtractions, you need to start with the leftmost addition or subtraction, and then you need to go forwards. So here we first need to perform we have these additions and subtractions. They are all of equal precedence. Which one should be performed first? The leftmost. So first we need to perform the leftmost addition. So let me underline it. Here we perform this multiplication first because the rules of precedence, they dictate it so. Okay. So first we perform this operation. Okay. And then we did this one. This is clear. So here we have addition and subtraction. All have equal precedence. Which one should we perform first? We should start from the left. So the leftmost needs to be performed first. Okay. So what would you get when you do this addition? You will get 7, then plus 6, minus 3, plus 1. So you get this intermediate expression. Now it also has multiple additions and subtractions. And which one should be performed first? The leftmost. So first you need to perform this addition. Okay. So what would you get when you perform this addition? You'll get 13 minus 3 plus 1. Okay. So now what should you do? You should perform this subtraction. Okay, the leftmost first. So what would you get when you do 13 minus 13? You'll get 10 and then plus 1. So the answer would be 11. Okay, this is simple. Now this can get tricky in the case of uh, this operator, the exponentiation operator. Let us go here. So for example, if you have this particular expression, okay, say for example we have this expression, uh, 3 raised to the power, say, or say 4 raised to the power 3 raised to the power 2 raised to the power 1. Okay, so say for example we have this expression, and let us increase its font size. Now here it matters a lot, like which way should the operation start. If you start from here, you will get a completely different expression answer. If you start from here, you will get a completely different answer. So here we have multiple exponentiations. Which exponentiation should be performed first? This one or this one? Okay, should we start from left or right? So the rules say, although they have equal precedence, but the rule of associativity says that we should perform the leftmost exponentiation first. Let us do that. 4 raised to the power 3. So 4 square is 16, and 4 raised to the power 3 is 64. Okay, so 64 raised to the power 2 raised to the power 1. Okay, so next we have two exponentiations. Which one should we perform first, this one or this one? Okay, so the rules say we should perform the leftmost. 64 raised to the power 2. Now I don't know what is 64 raised to the power 2. Like I cannot do it using just my memory. So let us take some help from Octave. 64 raised to the power 2 is 4096. 4090. We could have found it out, but I guess I got a little bit lazy. So now you can perform this exponentiation. So anything raised to the power 1 is 4 raised to the power 96. Now if you change the rules of precedence, if we did not know, sorry, associativity, if the associativity was different, then the result would have been different. If you started from here, say, 2 raised to the power 1 is 2, and then 3 raised to the power 2 is 9, and then 4 raised to the power 9, that might have been something different. Okay, so this is what you get when you evaluate this expression. We can test it in Octave. Like we can copy this command and we can paste it here. Okay, and you see the answer is 4096. So we evaluated this expression correctly. So I hope like you know the difference between operator precedence and associativity. Let us look at a couple of other expressions. Okay, these are examples. So one is 10 divided by 5 multiplied by 2. 10 divided by 5 multiplied by 2. So let us look at this expression. 10 divided by 5 multiplied by 2. Now here we have division and multiplication. Both have equal precedence. Both have equal precedence. So which one should be performed first? The leftmost. That is what the rule of associativity dictates. Okay, so we should first do 10 divided by 5. This would be 2. Then we should do this multiplication. So the answer would be 4. And you can verify it. You can verify it using Octave. 10 divided by 5 multiplied by 2. So the answer is 4. Okay. Let us use this clear command window command so that you can see these results here. So this is what we evaluated. Similarly, let us look at this expression. This is a bit longer. 5 multiplied by 2 raised to the power 3 plus 4 multiplied by 2. Okay. So let us see how this expression would be evaluated. Let me copy this slide and paste it. Okay. Let me get rid of these and these. Okay, so let us evaluate. What was the expression? 5 multiplied by 2 raised to the power 3. 5 multiplied by 2 raised to the power 3. Let us insert a space character in between. It's not required, but it makes it clearly readable, and I need to underline things. Plus 4 multiplied by 2. Plus 4 multiplied by 2. Plus 4 multiplied by 2. So how would this expression be evaluated? Okay, so again it has exponentiations and multiplication and addition. So the first thing that needs to be done, we need to look at the precedence. The highest precedence is that of exponentiation. Okay, so exponentiation. So first we need to perform exponentiation. First this expression will be, this operator will be performed. This operation will be performed. So the result would be 5 multiplied by 2 raised to the power 3. It is 8 plus 4 multiplied by 2. Next we have in this expression, in this intermediate expression, we have multiplications and addition. So multiplication has higher precedence. Now we have two multiplications. Which one should be performed first? So the leftmost should be performed first. Okay. So we need to perform this one first. So this would be 5 8s are 40 plus 4 multiplied by 2. Okay. Here we have addition and multiplication. So multiplication has higher precedence. So it needs to be performed first, and then you can do the addition. So it is 40 plus 8, and you'll get 48. Okay. So that is the answer that you'll get. You can type in this expression on the Octave command window, and you'll see that is the result. Okay. I'll leave that to you as some practice. Again, we can do it. I can also like do it here and show you that we calculated it fine, and we have 48 as the answer. Next is minus 1 raised to the power 4. So how would that be? Minus 1 raised to the power 4. Now here we have minus 1 raised to the power 4. Now this minus is not a subtraction, this is a negation. Okay, this is a unary operator. Unary operator takes only one operand, so it will basically negate the result. Now what will happen is first the exponentiation will be performed, and then the negation will be performed. So this is going to be performed first. Uh, so first the exponentiation is performed. So 1 raised to the power 4 is 1, and then the negation is performed. So the result would be minus 1. Okay, and you can verify it here. Minus 1, sorry, minus 1 raised to the power 4. So this is minus 1. Okay. Next is 8 raised to the power 1 by 3. Now this again is tricky. 8 raised to the power 1 by 3. Okay. Why is it tricky? Let us see. So it is 8 raised to the power 1 divided by 3. Okay. So I said it is tricky because maybe in the first glance you might think, okay, this is how the answer should be. We are probably trying to find the cube root of 8. But you're not going to end up with the cube root of 8 because of the precedence of these operators. So we have two operations. One is exponentiation and the other is division. Exponentiation has higher precedence, so it is going to be performed first. So first you'll find out 8 raised to the power 1, which is 8. And then it will be divided by 3. So you'll get something like 2.66 or 667. If you round it off, so you'll get 2.667, something like that. Okay. You can try it out here. 8 raised to the power 1 by 3. This is 2.667. Okay. If you want to find the cube root of 8, then you need to enforce precedence. Okay. You need to perform this division first, then, and then exponentiation. So how do you enforce precedence? You need to use parentheses. Okay. So then you'll find 8 raised to the power 1 by 3. So you're going to get the cube root of 8. So in this particular case, first the expression inside the parenthesis, which is 1 by 3, that will be evaluated, and then the exponentiation. So it will evaluate as 8 raised to the power 0.33333. So you'll get kind of the cube root of 8, okay, which is 2. Okay, so I hope you know what do we mean by operator precedence and associativity, and what is their impact. So you should be able to use these you should be able to evaluate these expressions. And if you have a normal like expression that you want to calculate using Octave or Matlab, you should be able to do the conversion. We'll go through a couple of examples there. Okay, I guess we have talked about it. Let me look at those examples. First, we are going to look at those examples, then we'll return there. Okay, so say for example you have this expression like this, a square plus b square, or this thing. So let us try it with numbers. If you have to find out, say, 2 square plus 3 square, how would you do it? Okay, so you can do it like this. So you want to find out 2 square, 2 square plus 3 square. So here, like, we have exponentiation and addition. So it is kind of simple. Exponentiation has higher precedence. So first, this exponentiation would be evaluated. First, you'll find 2 square, that would be 4, then 3 square, 9, and then they will be added. 2 plus 9, 4 plus 9, 13. So you'll get this answer 13. Okay. Let us look at this one. For example, if you want to find out 5 plus 20 the cube root, or 9 plus 7 plus 20 the cube root, for example. Now this might be a little tricky. Okay. So we want to find out the cube root of 9 plus 20. So how are you going to do it? Is this going to be fine? Cube root. Okay, 9 plus 20 raised to the power 1 by 3. So if you do it this way, this is going to be a complete disaster. Why? Because first the exponentiation will be evaluated, 20 raised to the power 120. Then the division will be performed, 20 divided by 3. That would be 6 point something, 6 point maybe 666, I don't know. And then the addition will be performed. So you will completely get the wrong result. If you want to find out the cube root of 9 plus 20, so you need to use parentheses. So we need to enforce precedence. We need to perform this addition first, and we need to perform this division first, and then we need to perform the exponentiation. Okay. So first this addition, 9 plus 20 or 7 plus 20. Let us make it 7 so that it is 27. 7 plus 20. So we need to perform this addition first. 27 raised to the power 1 by 3, 0.333. So we are now going to get the cube root of 27, which is going to be 3. Okay, but if you do it without the parentheses, then you are going to get a very strange value. So this is basically, you need to understand that if you have a normal expression like you usually have, and you want to convert it, and you want to uh, translate that expression into an equivalent Octave or Matlab expression, you need to be careful. Okay, so if you do it directly like this, you are going to get the wrong result, 13 point, which is not the cube root of 27. This is not what we wanted to find out. Okay, let me clear the command window again, and let us get back to our discussion. Okay, so the Octave environment, I guess we talked about it. It has both command line and GUI interface. Right now we are using the graphical user interface. You can try the CLI interface. What you do is you enter command and press the enter key, and then the command is executed. Octave is an interpreted language, which means that each command is converted into machine code or executed after it has been typed. So you enter the command, you type the command, you press the enter key, and it is executed directly. Okay, there is no translated code. No translated code, machine code is generated in between. Okay, so this is slightly different than compiled languages like C++. In those languages, you first write the whole program using an editor, and then you compile that code into machine code. So a separate file is generated, and that machine code is stored in an executable file then. And then you execute that file by double clicking on that file and loading into the random access memory. So compiled programs are better in the sense that they are faster. Compiled programs are faster. Interpreted programs are slower, much slower. So they're not meant for performance, but interpreted languages, they allow you to test your ideas quickly. Okay, that is what their primary advantage is. Okay, next we are going to start talking about variables. We said what are variables. Variables are basically named location in the computer's random access memory, and they are used to store data. Computers are data processing machines, and if you have to process data, if the computers have to process data, they need to have some mechanism for storing that data and accessing that data and then using that data for processing. Okay, so variables provide you with this mechanism through which you can store data, and then you can use that data, access that data, and you can use it. Okay, so what are variables? Technically, they are named locations in the computer's random access memory. So whatever variable you create, it resides in the RAM, and you can access it using the name that you give it. The name that you give to a variable is called an identifier. Okay, an identifier identifies a variable, and it is used as a handle to access and manipulate the value of the variable. You can use the identifier to access the variable's value, or to change it or modify it, whatever you want to do with it. Now, Identifiers, they need to follow. If you want to name a variable, you need to follow certain conventions, certain rules. Okay, so a variable name can be any letter or combination of letters. You can use a single letter as a variable name or a combination of letters. The letter can be uppercase or lowercase or a combination of both. But you must know that uppercase and lowercase, they are different. Small a is different, capital A is different. They will result in the creation of different variables. Okay. Okay. Uh, just wait for a couple of seconds. Okay, so we were talking about variables. Let us resume our discussion. So Octave is case sensitive. There's a difference between small a and capital A. If you name one variable as small a, you can create another variable with the name capital A. So they will be treated as two different variables. Okay. So what you should do is, how should you name variables? So a variable name can be any combination of letters. Letters can be both uppercase and lowercase. You can also use digits, numbers 1, 2, 3 as part of the variable name. Like you can have variable A1, A2, A3, B1, B2, B3, etc. You can also have underscores as part of the variable name. Underscore, it is a character that you can find uh, on your keyboard. If you look at your keyboard and you look for dash characters, so if you you'll find dash, and below dash there is a small dash. That is the underscore character. So you have to press the shift key and then the dash character to get underscore. I'll show you how. Okay, that is how. One thing you should remember, that you cannot create a variable by the name with a name that starts with a number. So a variable's name cannot start with a digit, 1, 2, 3, 4, any digit. Okay, so you cannot start a variable's name with a digit. You must know that. You must remember that. Moreover, you should avoid using names such as I, J, pi, because they mean something specific. Similarly, length, character, plot, size, break. Now these are function names, built-in function names in Octave. So we'll talk about functions. A function is basically a block of code, a set of instructions that do something specific. That do, for example, cos is a function that calculates the cosine of an angle. Plot is a function that creates a two-dimensional plot. Okay. Uh, Similarly, size is a function that determines the size, number of rows and columns in a vector or matrix or any variable. Length determines the number of elements in a vector. Okay. Similarly, pi is when you write pi, you basically get the value of pi. Okay, so if you write pi, if you type pi and press enter, so you'll get the value of pi. Okay, so pi is already predefined, so it means something specific. So you should not be using pi as a variable, as an identifier. Okay, you should not be doing that. That might lead to some confusion. Now I, like, you should not be using it as a variable. I also means something specific in the context of complex numbers. So if you press I and if you type I and then press enter, so this is basically iota, or the complex part, the imaginary part of a complex number. Okay. Similarly, uh, J also means or stands for the imaginary part of a complex number. So it has the real part of it is 0 and the imaginary part of it is 1. So I and J, they have specific meaning in the context of complex numbers. Okay. So you should not be using these as variable names. Similarly, these other functions, we'll go through these. So you should, ideally, you should name a variable that reflects the purpose of that variable. Okay. So the name should be meaningful name. A variable should have a meaningful name. Now let's see how do we create a variable. Okay, so how can we create variable? Let's see. So let us create variables, some variables. Let us clear the command window So let's suppose we want to create a variable. Let us call that variable as a, small a. So we want to create small a, and we want to store a scalar value in small a. So how can you do that? So you can say a and then followed by this sign of equality, but it is not the sign of equality. This here is the assignment operator. Okay, so let me note it down here. So when we say a is equal to capital A or small a, doesn't matter, 56 say for example. So a is the variable, this thing is the assignment operator, assignment operator. What it does is it calculates the value of the expression on the right and assigns or copies it into the variable to its left. Okay, so on the right we have 56. It's not an expression, just it's a very simple expression with just one constant value. So it copies that value into the variable a. Okay, that is what the assignment operator does. So we have a is equal to 56 for example. So 56, the value 56 is copied into the variable a. So now if you look at your workspace window, you have another variable by the name of small a, and its type is double. By default, any variable that you create in Octave, its type is double. It can store double values, okay, double precision values. Its size or dimension is 1 by 1, so it is a scalar. One row, one column, it is a scalar value, and its value is 56. Okay. Okay. So let us create another variable. This time say capital A, and we say capital A is equal to 56 multiplied by 5. Okay, say for example. So now this is the assignment operator. We read it as is equal to, but it's not equality. It does not test whether capital A is equal to this thing. It does not test that. Okay. For that we use another operator, that is the equality operator. We'll show that as well. Okay. So this is the assignment operator. So it assigns whatever is the value of the expression on the right. So now we have an expression here. Let us add some more terms to it. Okay. So now we have an expression 56 times 5 plus 23. So first this expression will be evaluated, and whatever result you get, that will be assigned to the variable on the left. Now this variable does not exist, okay, as you can see. So this variable, a double variable, will be created in RAM. 8 bytes of memory would be reserved for it, and then this value will be calculated and assigned to it, copied into it. Okay. So the value comes out to be 303. The value comes out to be 303. So A is of type double, it is scalar. Although it's an expression, but this expression evaluates to a scalar value, which is 303. Okay, so this is how you can do it. This is how the assignment operator works. We can also have variable names like this. We can say, now we can create a different variable. We can say a1, and we can say a1 is equal to a plus capital A. Okay, so a1 is equal to a plus capital A, small a plus capital A. Now these are two different variables. Small a has the value 56, capital A has the value 303, so this would be 359. A1 would have the value 359, so you will have another variable of type double created. The default type is double. It is a scalar variable and its value is 359. Okay, so you can do all these things. Okay, so this is how you create a variable, and this is how you assign values to it. Now we said we said that this is the assignment operator. Although we say a1 is equal to a1 is equal to a plus a, but we do not mean the equality. We are not testing equality here. Okay, for equality there is a different operator, and equality operator is a relational operator. It determines the relation between two values. For example, like we can say something like this. We can say a, and then we can put this double equality operator. So now this symbol, the is equal to symbol repeats twice. Now this is the equality operator. Okay, this is the assignment operator. Okay? This is the assignment operator, and this here is the equality operator. Is the equality operator. Okay. Now it is a relational operator. It is a relational operator which tests whether left hand side is equal to right hand side or not. If it is equal to, it will return true or 1. If it is not equal to, if they are not equal, the left hand side and right hand side, it will return 0 or false. Okay. So we can say, is small a equal to capital A? So now you can read it, is small a equal to capital A? We are asking a question. We want to compare small a and capital A. If they are equal, we will get true or 1. If they are not, we will get 0. So answer is 0, that means false. Small a is not equal to capital A. Small a is not equal to capital A. Now if you look at ans, the type of ans is logical. So ans now stores a logical value, 1 or 0, true or false. So 1 is true and 0 is false. So it returns the relational operator, any relational operator, it always uh, results in a logical value. Logical value. Logical value is, what do we mean by that? It is either true, which in this case is 1, or false, which is 0. So computers are binary digital devices. They use these ones and zeros to show all these values. So it uses true, it returns like any logical operator, it returns a logical value. The logical value is either true or false, two possibilities. True is represented by 1, false is represented by 0. So here we ask this question, is small a equal to capital A? And the answer was no. So you can also, you can ask this question as well, is small a equal to, what is the value of small a? 56. So the answer would be yes, 1. Okay. You can test some other condition as well. Is small a equal to capital A minus, sorry, say, is small a equal to capital A minus, say for example 300? Is it equal to that? No. Is small a equal to say capital A minus capital A minus what? So 350, 257, 257. No. What is A minus 257 equal to? What is A minus small a? 247. Okay. So we can ask, is small a equal to A minus 247? Then the answer would be yes. So you can test expressions as well. So you have this variable, and on the right hand side you have an expression. So the value of the expression would be evaluated, and then that value would be compared to the value of the variable on the left hand side. If they are both equal, you will get the result true, 1. If they are not equal, you will get the result false. Okay. So that is how we can create variables, and that is how we can use them. So we have created all these variables, and we use these variables in an expression. Like you can use those variables. So for example, if you are creating this expression, a1 is equal to a plus capital A. So this expression would be evaluated. First, the right hand side would be evaluated. So the value of small a would be fetched, and the value of capital A would be fetched, and they will be added together. So small a is 356 and capital A is 303. 56 plus 303 is 359. And this value would be copied into A1. Similarly, we use the values of these variables in this expression. This is not an arithmetic expression, this is a relational expression. Okay. So the result of this expression would be either a logical value, either 0 or 1, true or false. Okay. So we are comparing right hand side and left hand side. Right hand side is this expression, a capital A minus 300, which would result in 303 minus 300 is 3. Is 3 equal to 56? No. So that is why we get the answer 0. Okay. So this is how we can create variables and we can use those variables. And in this slide we basically explain that, like what happens when we create when we write a statement like this. So this is what happens. We've talked about it. Okay. So we can always reassign a new value to a variable. So right now a, what is the value of a? If you want to know the value of a variable, you can simply type a and then press enter, or you can say display a. So you can call the display function, and display function will display the value of a. A is equal to 56. So either way you can know the value of a variable, okay, just by typing its name and press enter, or by calling the display function. Okay, so you can know its value. You can reassign a variable a new value. So a is equal to 56 right now. You can say a is equal to 89. Okay, so now a will have a new value 89. The previous value 56 is gone. You can reassign it a new value. You can say a is equal to 98.89. So now a will have this value 98.89. Okay, so you have reassigned it a new value. Similarly, we can say a is equal to the previous value of a plus 100. Okay, so the new value of a is the old value of a plus 100. Now on both sides, the left hand side has a and the right hand side has a. So but I'm calling this one, this a as the old value or previous value of a, and this a as the new value. They are the same symbols, the same identifiers, same variables, but this value is fetched before. Like we want to assign a new value to a, and how that value is going to be calculated. That value is going to be calculated by getting the value of a itself and adding 100 to it. Okay, so that's why I'm calling it the previous value of a. So you can assign a new value to a variable like this as well. Okay, so now a is 198.89. If I repeat this statement, so the next would be 298.9. Repeat it again, 398.9. Repeat it again, 498.9. So the new value is 100 more than the previous value. So this is how you can increment the value of a. Okay. Okay. Similarly, here I talk about something else. For example, this is a. So a is equal to a plus 100. So the new value of a is the previous value of a plus 100, and that value is printed. Now if I make a small change here, I just put semicolon here. So and then press enter. So now I won't get the new value of a printed on the screen, but the value of a changes nevertheless. So the new value of a is 698.89. So if you want the output of your command to appear on the command prompt, on the command window, you should not insert a semicolon here. But if you want to suppress the output, you don't want the new value of a to be printed here, then you should put a semicolon here. For example, if I repeat this command, a is equal to a plus 100, so the value of a will be changed, but it will not be printed on the display screen. So now it is 798.89. Okay, but it's not being printed here. If I remove the semicolon, so a will be incremented and the new value will be displayed on the command window, 898.89. So you should remember this as well. Okay, similarly, like this small a that we have, in fact, all the variables that we have created so far, they are all scalars. Okay, their dimension or their size is 1 by 1. So we can create vectors as well. Okay, so let us create a vector. So let's say we have a1. Right now a1 is 359. Okay, so we want to reassign a1 a new value. So I want a1 to become a vector. Okay, so how can I do that? So what is a vector? A vector has multiple components. Okay, So right now, say from physics, you know that if you have a vector, um, you can resolve that vector into its rectangular components, say for example. And rectangular components in 2D are the x component and the y component, and in three-dimensional space, it is the x, y, and z component. And you can have non-rectangular components of a vector as well. Okay, it's not necessary, but what it means is that uh, if you resolve a vector into its components, then the vector has many subvectors, which if added together will give you the original vector. So you can specify that here in Octave as well. For example, we can create a vector with three components. And how would you do that? So you would use these square brackets. Inside these square brackets, you'll specify the different components of a vector. Okay, so for example, A1. A1 is this vector, or let me call it R1. Okay, R1 is this vector. Say for example, 1. This is the first component. 5. This is the second component, and say minus 3. This is the third component. So 1 and then a space character, 5, then a space character, and minus 3. So this is a vector with three components. Okay. When you press enter, so this is what you see. So you have created a vector R1. It is a row vector. This is one row with three columns. Okay, one row with three columns. So it is a row vector. R1 is a row vector and it has these three components. Each component is separated from the next one by a space character. Okay, so here you put a space character. You can also put a comma. Like we can create another another vector. Let it be a row vector R2, and we can say R2 is equal to 4 comma 8 comma minus 9, or 9 say. Okay, and press enter. So now you have R2, a row vector, 4, 8, 9, with these three components 4, 8, and 9. So this is another row vector. Okay. Okay. And similarly, just like the arithmetic operations, the way they apply to scalars, similarly those operations also apply to vectors. Okay. And that is the beauty of Octave. Like, it is very simple, extremely simple to add vectors, scalars, and matrices. The only thing that you should be careful about is their order. Like, we can add R1 and R2. So we can have another vector R3. Let us create another vector R3, but R3 is going to be R1 plus R2. So you can add R1 and R2 and create another vector R3. Okay. So they can be added together. They have the same order, one row and three columns, both of them. So if you add them, so automatically they'll be added by the element by element addition would be carried out. Okay, so 1 plus 4, 5, 13, and 6. So you will have this vector R3 is equal to 5, 13, 6. So they'll be added together. If you look here, so R1 is a variable. Its type is double. Each element of R1 is stored as a double variable. So R1 will take 8 multiplied by 3, 24 bytes. 24 bytes for R2, 24 bytes for R3. Its size is 1 by 3. 1 row, 3 columns. Okay, 1 row, 3 columns R2, and this is its value. Similarly, R3 is like this. Okay, so this is how you like create vectors, and this is how you like what can we say, operate on them. So similarly, you can subtract them. We can also say R we can say R3 is equal to R4 is equal to R2 minus R1. Okay, R4 is equal to R2 minus R1. So you can do this subtraction like this. So what is R2? R2 is 4, 8, 9. So 4 minus 1 is 3, 8 minus 5 is 3, 9 minus 3 is 9 plus 3, which is equal to 12. So you can do this addition and subtraction. Can you do multiplication? Can you multiply R1 and R2? So multiplication of vectors is slightly different. Okay, so you cannot do multiplication like that. You cannot do the vector multiplication. Okay, why? Because their order doesn't match. You cannot multiply a row vector with a column vector. You cannot multiply a row vector with a column vector. Okay, so this is a row vector. 489 is a row vector. So sorry, you cannot multiply two row vectors. You cannot multiply a row vector with a row vector. You can only multiply a row vector with a column vector. Okay, so a row vector can be multiplied only with a column vector. So we cannot do something like this. We cannot say R5 is equal to, or we cannot say R1 multiplied by R2. If you try to do that, so you will get this error message that these are non-conformant. Okay, so both the operands are row vectors, so you cannot multiply row vectors like that. Okay, so you can multiply a row vector with a column vector. For example, this is a row vector R1. Let us create a column vector, say C1. How can you create a column vector? So how do you specify column entries? So in order to specify column entries, you need to uh, do something like this. Like you need to use these square brackets, and then this is, say, the first value 7. Then the second value. How do you separate these two values? You use the semicolon character. Okay. So C1 is basically your sorry, the column vector that you want to create. This is the element that goes into the first row, followed by a semicolon, then element that should go into the second row, followed by a semicolon, and then element that goes into the third row. Okay, so this is how we create a column vector. So now C1 is a column vector. Okay, so you specify it has one column and three rows. So you specify a new row by using the semicolon character. When you put the semicolon character, you basically specify the tell the Octave interpreter that you are going to create another row. The next element should go into the next row. Okay, so now R1 is a row vector and C1 is a column vector. You can multiply these two. So if you say R1 multiplied by C1, so you can do that. Okay, so how would this multiplication go? R1 would be multiplied with this. So 1 multiplied by 7 plus 5 multiplied by 5 plus minus 3 multiplied by 3. Okay, so 7 plus 25, that is 32, minus 9, I guess that is 23. So you'll get 23. That is how they will be multiplied. Okay, now this is the beauty of Octave Live. It makes operating or working with vectors and matrices very easy, extremely easy. Okay, uh, if you want to do something like this in languages like C or C++ or Visual Basic or Java, if you're not using specific libraries for the purpose, and if you have to write code in that language directly, so that will take a lot of effort. Like if you can ask your colleagues, your friends from other departments who study, say, C++ instead of Octave, who use that. So that is not to say that C++ or those languages are useless or they shouldn't be um, used. They have their own advantages, and this language has their own advantage. Now we have created a row vector and a column vector. Time to move on to matrices. Say we want to create a matrix M1. Okay, so what is a matrix? A matrix has multiple rows and multiple columns. So let us create a 3 by 3 matrix. Okay, so how can we do that? So we can create a 3 by 3 matrix like this. So again, you have to use these square brackets. So you specify the elements of the first row, then the second row, then the third row. So or you have to like write or provide three row vectors together. Okay, so the first row vector, then you have to say that I want to create the next row vector, then the next row vector. So how did you create the row vector? So this is how you created row vector 4, 1, 3. This was your row vector. Okay, and if you remember the way we created column vector, so we specified entry for a row, then we said now we want another row, and we did that by using the semicolon character. Okay, so 5, 7, 6. So this is, or say 1, or say 2, 5, 7, 2. So this is the second row vector, and now we want to provide the third row vector. Okay, So the semicolon, we use the semicolon to specify that we want to have another row. So this is the first row, this is the second row, and then we want to specify the third row, which is 8, 0, 7, say. Okay. So if you press enter, this is what you're going to get. M1 and so this is what M1 is. So we specified M1 by specifying individual rows. Okay, so we specified 3 row vectors: the first row vector, second row vector, and third row vector. This is how we did it. Okay. Now, if you remember, we already have these 3 row vectors: R1, R2, and R3. Okay. So we can create a matrix like this as well. Let us create another matrix, M2. And M2 can be created by specifying row vectors directly. Like we want R1 row vector, then we want to have R2 row vector, then we want to have, say, R3 row vector. So we want to have these 3 row vectors, one above the other. Okay. If you press enter, you will have M2. So this is R1 153, then followed by R2 489, then followed by R3 513 6. And again, subtraction, addition, subtraction. So it's fairly easy if the orders they match, if they are compliant for addition. So you can simply say M1 plus M2, and these two will be added together: 4 plus 1 5, and 5 plus 4 9, and 8 plus 5 13. So you can verify that it basically checks out. You can do a subtraction, M1 minus M2. You can do that. Okay. And they are 3 by 3 order matrices, so they can be multiplied. So you can do M1 multiplied by M2. You can do that as well, and you'll get the product. Okay. So this is the beauty of Octave. You can work with vectors and matrices and scalars you can work with it very well, seamlessly, like without any problems or troubles. Okay. I guess this is enough for this lecture. After a short break, I'll start recording the next lecture, and then in the meanwhile, I'll upload this one to YouTube. Okay. Okay. See you then.